Today, we're diving into one of the most powerful and, frankly, life-sustaining climatic events on the entire planet, the Indian monsoon. And believe me, it is so much more than just rain. It's this colossal weather engine that literally shapes the lives of an entire subcontinent. And trust me, that is no exaggeration. This isn't just some weather pattern we're talking about. It's a rhythm, a pulse that dictates the cycles of nature, of agriculture, and even culture across all of South Asia. It's that fundamental. And this is why it matters so much. More than 1 billion people. Let that sink in. More than 1 billion people directly depend on these seasonal rains for their food, their water, their entire economy. The stakes just could not be higher. So you have to ask, right? How does this massive engine actually work? And maybe more importantly, why is it becoming so dangerously unpredictable? We're going to break down the mechanics behind it and explore how climate change is completely rewriting the rules for this vital system. Okay, first things first, let's pop the hood. What actually makes this massive system tick? It turns out it's this fascinating combination of geography and pure physics. So the basic principle, and get this, was first figured out way back in 1686. During the summer, the huge Asian landmass heats up like a skillet on a stove, much faster than the Indian Ocean next to it. This creates a giant low-pressure area that acts like a vacuum, just pulling in all that moist air from the sea. And that's it. That's the ignition. But what gives the Indian monsoon its unique, incredible power? Well, a huge piece of the puzzle is the Tibetan Plateau. I mean, this thing sits at over 4,000 meters high. It acts like a massive elevated heater in the sky, supercharging that low-pressure system and turning a regular engine into a real high-performance machine. But the engine can't just run whenever it feels like it. The timing is all controlled by these high-altitude rivers of air we call jet streams. For the monsoon to even begin, the subtropical westerly jet has to physically shift north of the Himalayas. Think of it like someone flipping a giant atmospheric switch. It removes the high-pressure cap over India and just allows the monsoon to surge right in. So, once that switch is flipped and the engine is running, the monsoon begins this incredible journey across the subcontinent. Let's trace its path. You know, the monsoon isn't just a single event. It's more like a 4-act play. It starts with this dramatic burst in the south, then it advances across the whole country. Then it begins a slow retreat, and it even has a second act, the northeast monsoon, that brings rain to the other side of the coast. And India's own geography really shapes this whole journey. The peninsula splits the monsoon into 2 arms. You've got the Arabian Sea branch, which just slams into the Western Ghats. And then there's the Bay of Bengal branch, which curves around the Himalayas to water the vast northern plains. The result of this complex trip is an absolutely incredible variation in rainfall. On one hand, you get places like Monsoon in the northeast, which gets over 10,000 millimeters of rain, making it literally the wettest place on Earth. And on the other hand, you have Ladakh, which is shielded by the Himalayas and remains a high-altitude desert. It's just wild. But here's where it gets even more complex. The monsoon isn't just a local affair. Its performance is often dictated by massive climate patterns that are happening thousands of miles away, acting like, global remote controls. The biggest player on that stage is the El Niño phenomenon in the Pacific Ocean. Basically, El Niño, with its warm Pacific waters, tends to disrupt air patterns and really weaken the monsoon, often leading to drought. But in contrast, its cooler counterpart, La Niña, usually strengthens the monsoon and can sometimes cause some pretty serious floods. But forecasting isn't as simple as just watching the Pacific. Nope. The monsoon has another trick up its sleeve. And this one's a lot closer to home. And this is the Indian Ocean Dipole, or IOD. It's the Indian Ocean's own version of El Niño. A positive IOD, where the western Indian Ocean is warmer than the east, can actually counteract a weak El Niño and deliver a totally normal monsoon. This interaction adds a huge layer of complexity, which makes accurate forecasting a massive scientific challenge. And now, of course, we come to the great disruptor of our time. Climate change is taking this already complex system and just making it more volatile and more extreme. This brings us to what scientists are now calling the monsoon paradox, and it's pretty worrying. We're seeing a sharp increase in these extreme, really destructive rainfall events, but at the same time, the total number of rainy days is actually decreasing. So the monsoon is delivering its water in shorter, more violent, and ultimately far less useful bursts. And the rain isn't just changing in character, it's changing location. Over the last decade, over half of India's districts have actually seen an increase in monsoon rain, especially in arid areas. But, and this is crucial, 11% have seen a decrease, and many of them are in the critical agricultural heartland of the Indo-Gangetic Plain. And the pressures just keep mounting. You've got melting ice in the Arctic that's altering global wind patterns. The Indian Ocean itself is warming, which can weaken that fundamental temperature difference that drives the monsoon in the first place. And even pollution and the growth of cities are having an impact, creating these intense, localized flash floods.
So with all this change, how is India adapting? I mean, how do you manage a system that is becoming so fundamentally erratic?
This quote perfectly captures the stakes. There's a famous saying that the monsoon is the real finance minister of India. Its performance directly impacts the country's GDP, food prices, even the energy supply. A good monsoon can boost the economy, a bad one can trigger inflation and real hardship. It truly holds the country's economic fate in its hands. In response, India has been building a really sophisticated framework. It started with disaster management, but it's evolved into this massive scientific push. From the National Monsoon Mission to the new Mission Monsoon, the goal is to use supercomputers, Doppler radars, and advanced modeling to get ahead of the weather. And this brings us to our final thought. The relationship between India and its monsoon is being completely redefined. For millennia, it was a predictable, life-giving rhythm. Now, it's a volatile, unpredictable force. The challenge ahead is immense, and it leaves us with a critical question. As this ancient weather engine changes right before our very eyes, can our science and our systems possibly adapt fast enough?